Okay, Year 10, we're beginning our new unit, and this unit is on equations. Now, when we talk about equations and we're using algebra, what we're doing in most cases is trying to solve these equations. Now, I like this idea that they've got it here because when you solve an equation, and remember, an equation is just an algebraic expression with an equal sign. And I like this idea of the cricket batsman because when you're getting ready to bat, you will put on your socks, then your shoes, and then put your pants on then, and then you might have already got them on, and your pads. When the game is over, you don't try and take your socks off first. You've got to do it in the reverse order. So you take your pads off, then you take your shoes off, then your socks. And that's what you've got to remember with equations. We are trying to get everything off. We're trying to undress the equation. So when we look at an equation, we're trying to take things away. And to take things off or to undo things in mathematics, we call them inverse operations. So you have a set of things you call operators or operations that you can do. And you already know those. And the operations are where you can add things, you can minus things, you can multiply things, you can divide things. We also know you can raise things to a power, or you can take the root of something. And there are other things that we're going to learn to do later on, but they're our basic operators. Well, every single one of these has an inverse operation. That is the operation that undoes it. Some people like to call it opposite, but the real word is inverse because you could use the word opposite, but inverse is much better. So to undo adding, well, we minus. To undo minusing, we add. To undo multiplying, we divide. To undo dividing, we multiply. To undo raising something to a power, well, we take the root. And to undo something being rooted, or square root, cube root, we raise it to a power. And there are our basic operations and our inverse operations. You must know what the inverse operation is. So, before we begin though, this goes back to the beginning. Before we begin, we need to understand that every equation, well, sometimes they're not, they do not have a solution, they're insoluble, but every equation has a solution. So if we look here, decide whether x equals 2 is a solution. Well, we've already done this work previously. All you've got to do is to see if it's a solution is put the number in for x and see if it works. So for question 1a, and you can always test this, and this is the beauty, all right? And it's the last thing on the success criteria. And if you look at our classroom, you'll see number 4, I can check my answer by substituting back into the original equation. So if you think that x equals 2 is a solution, you just put 2 where the x is. Oh, 2 plus 3. Does that equal 5? Yes, it does. It works. Okay, let's try the next one. D. 2. Now remember there's a multiplication sign between that 2 and that x. 2 times, we put the 2 where the x is, minus 1. Well, 2 times 2 is 4. 4 minus 1. And we're trying to see if this equals 10. 4 minus 1 is 3. 3 does not equal 10. So 2 is not a solution to that one. Remember, and they line it here, you just work one side, whether the left-hand side equals the right-hand side. So there's my left-hand side, there's my right-hand side. And if they equal each other, away I go. All right, how do we do these equations? These are one-step equations. These are quite easy. These are all adding ones, so you'll fly through these. You have a go. T plus 5 equals 8. Now, you might be able to do these in your head, but trust me, we need to have a system. We have to get this t by itself, which means we have to get rid of that plus 5. Well, how do I undo it? Well, remember the inverse operation of plus 5 is to minus 5. Now, some people like to go, oh, well, minus 5 there and we'll minus 5 there. Some people just say, oh, take that 5 over there and minus it. I don't mind which method you use. But if you minus 5, that'll leave the t. You've taken it off. So taking the pads off, taking the shoes off. And 8 minus 5 is 3. And all of a sudden, bang, we've got our answer. And it doesn't matter even if there's nothing on the other side. Look at this one, m plus 7 equals 0. Now, you don't have to write minus 7 and minus 7 if you know what you're doing. You can just go straight to this. Well, if I minus that 7, 0 minus 7, negative 7. I'll try the last one, G. M plus 8 equals 40. All right, well, let's get rid of that 8. Minus the 8, minus the 8. I'm not going to write this all the time. 40 minus 8, 32. Here we go. Question 3. These are really easy. All you've got, these are one-step equations again. I've got x minus 3 equals 3. Now, this time, let's think about just taking that 3 over the other side. And to take it over, we add it. So we get 3 plus 3, which equals 6. It is the same thing. If I add 3 to both sides, I get the same thing. All right, let's have a look at the next one. D, x minus 3 equals 0. Again, that doesn't matter. Take the 3 over the side, add it, we get x equals 3. You see me do G before me. Add the 12. 12 plus 24, 36. Here we go, question 4. 8. Now remember, between that 8 and that p, I'm not going to write it anymore after this one, is a multiplication sign. So to get rid of that 8, I have to divide by 8. And that'll get rid of it. That takes it off. It's taking the shoes off or the pads off. And I get p, well, 24 divided by 8 is 3. Now, here's where you go, I'll just check because I'm a bit unsure about that. Our success criterion number 4 says, substitute it back in to see if you're right. Oh, well, 8 times 3, does that equal 24? Oh, yes, it does. All right. You have a go at the next two before I do. Fast forward if you get them. D, 2m equals 16. I'm just going to divide that 2 away. I'm going to divide 2. So I'm going to get m equals 16 divided by 2, which is 8. It's the same thing as dividing by 2 and dividing by 2. It is the same. The last one, G, 15p equals 15. All right, remember there's a multiplication sign there. I'm going to divide by 15, which will take it off. Divide by 15, which leaves me with the p and 1. Okay, 5. Here we go. X on 5 equals 10. Now, please remember that the vinculum in a fraction represents division. So to get rid of that 5, I'm going to times by 5 and I'm going to times by 5. That gets rid of the 5. I'm just left with the x. I've taken the 5 off. By multiplying by the 5, I've got rid of it. And 5 times 10 is 50. The other way to think about it, that was A. D, Z over 7 equals 0. I like to put a little dash on my Z so I don't confuse them with the 2. Let's multiply that 7 across. Some people like to think of it that way. It's exactly the same. 0 times 7, that's 0. Z equals 0. Don't let or get confused or worried if the pronumeral is on the other side. It doesn't matter. Maths is great. You can read it left to right and right to left. So I'm going to times by 7. That gets rid of the 7 that is with the R. And 7 times 8 is 56. And I'm just left with the R. And I can read it this way. R equals 56. Righto. I'm just going to create a little bit of... Oh no, I'm going to go beside myself here. So 6a. X plus 9 equals 12. You should be able to do this. Undo that 9. Minus it. X equals 12 minus 9. Oh, that's 3. Here's the next one. D. 3 equals X minus 7. Well, to get rid of that 7 and get the X by itself, which is what we're trying to do, I just have to add it. So add it over the other side. 3 plus 7. X equals 10. Doesn't matter that the pronumeral's on the left. G. 3x equals 9. Well, I've got to get rid of that 3. How do I get rid of that 3? I divide it. I'm just going to go, 9 divided by 3, that's 3. I'm hoping that you can do them in one step. Here's the last one, J. X on 5 equals 4. Multiply that 5 across. So to move the 5 over here, I multiply, and I get X equals 4 times 5, and that's 20. Now you should remember all this work from year 7 and 8. When I get down here to 7, all of a sudden there are 2 things happening to the X. Now this is where the order in which you take the things away is very important. So I've got 2x, and a good way to think about it is take the things that are furthest away first. So 2x plus 5 equals 7. I've got to get rid of the 5 and I've got to get rid of the 2. Which one do I take away first? Or which one do I get rid of first? Now normally, if this was just an operation where you had 2 times the number plus 5, you'd do the times first. But we're taking things off, so we've got to do it in the reverse order. So the first thing I'm going to do is I'm going to minus that 5. And you do it one step at a time. So I get 2x, and I get 7 minus 5, and that is 2. So I minused the 5, and I minus the 5. Now I'm going to get rid of the 2. I'm going to divide by the 2. That'll get rid of it, take it away from the x, it's taken off, and 2 divided by 2 is 1. Let's have a go at the next one. You see if you can do it before me. 6x plus 13 equals 1. Again, if you're unsure, the thing that is furthest away. So I'm going to minus the 13. You don't need to write this if you don't want. And that takes it away. And 1 minus 13 is negative 12. You've got to use your calculator here. 1 minus 13 is negative 12. Now I've got to get rid of that 6. All right, well, I'll divide by 6. And again, use your calculator. All right. So negative 12 divided by 6. Oh, hold on, I've got the answer there. Negative 12 divided by 6. Negative 2. And there you go. And you can check your answer. Oh, well, let's check it. Does 6 times negative 2 plus 13 equal 1? Well, I'll do that on my calculator. 6 times negative 2, I've got 8 in there, times negative 2 plus 13. Well, it does. 1 equals 1. Beautiful. Okay. Let's do 7g. 3x minus 4 equals 8. Again, you're going to have to get rid of that 4 first. Add it. 3x is 8 plus 4, 12. So I added 4 to take it away from there. It seems funny that you're saying, oh, to get it off, to take it away from the x, I added it. Well, you're doing the inverse operation. Now to get rid of that 3, I'm going to divide, and I'll get the x by itself, and I get 4. The last one, j, and again, they've put the pronumeral on the other side. If you really want to, you can write 2x minus 6 equals negative 10. I'm going to write it the way they've got it there. Doesn't matter if it's on the left-hand side or the right-hand side. If you wanted to, you could do this. If that makes it preferable for you, it doesn't matter. First thing I'm going to do, I'm going to add 6, and I'm going to add 6. I'd probably use my calculator here. I don't have to. I know that negative 10 plus 6 is negative 4. And I've got rid of the 6 over here. I'm now going to divide by 2 and divide by 2. Again, I suggest using a calculator. Over here, that'll get rid of the 2. So I've just got an x, negative 4 divided by 2, negative 2. Right. Down to question 8. 8a. X on 3 plus 2 equals 5. Well, what am I going to do first? Again, look to the thing that is furthest away. All right, if you're in doubt, always go to the thing that's furthest away. Well, that 2. Let's add the 2, subtract the 2. That gets rid of it. And I'm just left with x on 3. And 5 minus 2 is 3. Now I have to get rid of that 3. So I'm going to times the 3 and times by 3. And I will get x equals 9. Probably a good time now to just double check by substituting back in. So put the 9 where the x is. And does that equal 5? Well, let's use our calculator. Is 9 over 3 plus 2. Well, what does that equal? 5. And 5 equals 5. We know we're right. D. X on 4 minus 3 equals 2. Well, I've got to get rid of that 3. So I'm going to add 3. That'll get rid of it. And move it over to the other side, if you like to think. So I get x on 4 equals 5. How do I get rid of that 4? I multiply by 4, times by 4, times by 4. And I get x equals 20. So as long as you follow all these and you follow the process, you should be really right. Here's the last one in this question. Minus 6 or negative 6 equals x on 8 minus 2. Okay, again, you could write this as x on 8 minus 2 equals negative 6. If that makes it easier for you, and it does, just swap the things over the other side. They're both equal. You can put them on either side of the equal sign. It doesn't matter where you do it. Well, the first thing I'm going to do is I'm going to get rid of this plus 2, this minus 2. So I'm going to plus 2 and plus 2. Again, I would use my calculator, but you will find that you will get negative 4 equals x on 8. And now I've got to get rid of that 8. So I'm going to times by 8 and times by 8. And I'm going to get negative 32 equals x. Now that was a bit of a hard question, so let's check. Does negative 6 equal negative 32 on 8 minus 4? Okay, Well, negative 32 on 8 minus 4. Oh, we've done something wrong here. Oh, that's one. It's not minus 4. It's minus 2. Let's go back to our calculator. Much better. There we go. I don't know where I pulled that 4 from. Righto. Last questions. Now here. Again, this is a 2 operator. Now be careful. M plus 1 over 2. This is where you've got to be very careful. Most of you will probably go, oh, let's get rid of that 1 first. No. If you get rid of the 1 first, you're in trouble. You've got to get rid of this 2 first. Now, I know that's hard, but if this was a normal operation, you would do the number plus 1, then divide by 2. So if this was 5 plus 1 over 2, well, you do the addition first, then the division. But because we're taking things off, we must do them in the reverse order. So I've got to get rid of that 2 first. So let's times the 2 across. Might do it like this, might make it easier. M plus 1 equals 3 times 2, which equals 6. So M plus 1 equals 6. And then I minus the 1. M equals 6 minus 1, which equals 5. Remember, this is exactly the same as what we were doing before. If you like to go, oh, I'm going to times by 2, and then I'm going to minus 1, you get the same thing. This might be a good time to check. So, does 5 plus, that was lucky, 5 plus 1 over 2 equal 3? Again, go to your calculator. Bang. 5 plus 1 over 2 equals 3. Okay, 9D. X plus 5 over 3, does it equal, it equals 2. Multiply the 3 across, x plus 5 equals 6, minus the 5, x equals 1. That's how I do them. Right, I don't write the things in. You can if you want to, but you don't have to. G, W plus 4 over 3 equals negative 1. All right, multiply the 3 across. W plus 4 equals negative 3. That's a terrible plus sign, looks like a T. And then I minus the 4. W equals negative 7. I would have done that on my calculator. Remember, you're minusing the 4. If you go minus 3 minus 4, let's check this one because it looks a bit dangerous. Negative 7 plus 4 over 3, does it equal negative 1? Well, let's use our calculator. We'll just go backwards. Does negative 7 plus 4 over 3, what does that equal? Negative 1. We're okay. So yes, negative 1 does equal negative 1. We're right. The last one. And they just put everything over the other side. You can write it differently if you like. 2 equals a plus 7 over 4. 2 equals a plus 7 over 4. Let's double check, make sure that's the right equation. 2 equals a plus 7 over 4. We're doing J. Multiply the 4 across. All right, so times by 4. Times in by 4, we'll get rid of it over there, which gives me 8 equals a plus 7. Minus the 7, minus 7. 1 equals a. Let's check. Does 1 plus 7 over 4, is that equal to 2? Check on our calculator. 1 plus 7 over 4. 2. There we go. So 2 equals 2. So hopefully you're okay with them. If you want to do a few more, just choose a column, do a couple of random ones. Please remember that you must do, to solve an equation, you must do the inverse operation in the reverse order. All right? All right? You do the inverse operation in the reverse order. Good luck with that.